All right, this is another part of the final exam review for Math 137 for day 2, starting with number 25, part D, or actually that probably should be B, but I don't know why it labeled it differently. But we're supposed to be, I think it didn't copy correctly. Let me see. Those are the exact, no, they're not the same. Okay. So this is a triangle where we know it's not a right triangle usually. We're not being guaranteed that, so we're going to label this as C, A, and B. Doesn't matter which order, but I usually just do it the same way every time. Beta is 43.7 degrees. Little a is 56.7. And gamma is 104.5 degrees. Now, because you have two angles, you should be able to find the third angle by subtracting from 180. So 180 minus the 43.7 and minus the 104.5. That gives me 31.8. So that's going to be my alpha. And then I need to find little b and little c. So if I know an angle and a side across from it in any triangle, and I know another angle or another side, I can use the law of sines. So the law of sines says that if we do sine of 31.8 over 56.7, I have to use this angle and this side because that's the only two I have across from each other. And then I could try to find the longest side if I want to. So sine of 104.5 over, we'll call that little c. So we would cross multiply here. So this is going to be 56.7 sine of 104.5, and then you divide by the one that is connected to the c. So sine of 31.8. So we get 56.7 times 104.5 sine, enter, divided by 31.8 sine, and that's 104 point, what are we supposed to round to? 1 decimal, 104.2. And then we need to find the other side length. So I'm going to go ahead and write in the one we found. That was 104.2. And then we need to use sine of 31.8 over the 56.7 again equals sine of 43.7 over a, little b. We already have little a. So we're solving for little b this time. And if we cross multiply again, that's going to be sine of 43.7 times the 56.7 divided by sine of the 31.8. So I get 43.7 sine times 56.7 divided by 31.8 sine. That's 74.3. So there are the three missing pieces of that triangle. Notice we didn't have any ambiguity about whether or not there was going to be a second triangle because we already knew two of the angles. That forced the third angle to only be one possibility, because you have to have a triangle that adds up to 180, and there's only one way that can happen if you already know two of the angles. All right, so let's look at another version. We're going to do 26 next. So we're going to do A version. So, okay, for this one, I'm going to draw my picture. Looks like I know all three sides of the triangle this time. So we're going to have to use Law of Cosines. So little b is 52.3. Little a is 70. Oh, no, sorry, we know alpha. It's hard to read on this. So that's an angle. So 71.8. and little c is 65.4. We know all three sides on the next part, b. This is still a law of cosines because we don't have any way of finding the side across from this or either of these two angles. So we're going to be looking for the formula for law of cosines that has a by itself. So that's a squared equals b squared plus c squared minus 2bc, and then times the cosine of the alpha, the angle that is across from the little letter that's over here. So this is a squared equals b is the 52.3 squared plus 65.4 squared minus 2 times 52.3 times 65.4 times cosine of 71.8. Okay, we're going to work this out in pieces. So 52.3 squared plus 65.4 squared is 7,012.45 minus 2 times 52.3 times 65.4 times 71.8 cosine equals 2136633. Sure we got that right. Okay, so we'll subtract those two things, 7,012.45 minus 2136633. That's 4,875.817. And that's a squared. So we need to take a square root of that, which is to the half power. So 69.83 would be my approximation for little a. So let's write that in. So 69.83. Okay, now that is 2 decimal places like the directions, but I noticed on the answer key they have 69.8. So I don't know. Just following the directions, it's supposed to be 2 decimals. Now that we have this, though, we can use a law of sine, since we have a side and an angle across from it, to find a second angle. Depending on how you want to approach this, this is already the largest side of this triangle. So that means that this is the largest that an angle can be. So we know there's not going to be any obtuse angles in this problem. So I'm going to solve for little b. It's the smaller of the angles that I would be finding, so I know it's going to be an acute angle too. So this is sine of 71.8 over 69.83 equals sine of beta over 52.3. So we're doing 52.3 sine of 71.8 over 69.83, and that's equal to sine of beta, which means we're going to be doing a sine inverse of that once we get it worked out to find beta. So let's work out the inside first. So that's 71.8 sine times 52.3, and then divided by 69.83. That's 0.71149, and then we want to do an inverse sine of that. And that did not come out the right way, so hang on just a second. I think I hit the button twice. 71.8 sine times 52.3 divided by 69.83, and then inverse sine. Yeah, 45.36. So 45.36 degrees, since I'm going by the directions, and then we would subtract from 180 to find the other angle. So 180 minus 71.8 minus 45.36 is 62.84. And make sure this makes sense. Smallest angle, smallest side, medium angle, medium side, largest angle, largest side. So there is number 26A. For number 27, we have a landscaping professional is planting flowers in a triangular garden, because that's cool. And we know the side lengths of the triangle. And what we're trying to figure out is what is the area of the garden rounded to the nearest whole unit. So think about this being a B, and a C, and it doesn't really matter. I'm just going to kind of estimate this is 12, 16, and 18. Now, this is area, so it's set up really to do Heron's formula, which is you need the perimeter, which means you add all three sides together, and then we cut that in half to find what's called S in the formula. So let's first of all add that up. That's going to be 30 plus that's 46, and 46 cut in half is 23. So the way the formula works is that to find the area using Heron's formula, you take the square root of S, which is 23, times, and then you do each of the 23 minus each of the sides. So 23 minus 12, 23 minus 18, 23 minus 16. So let's work those out. So this is going to be, sorry, my calculator's acting funny. So this is square root of 23, and this is 23 minus 12 would be 11. 23 minus 18, I believe, is 5. And 23 minus 16, it's a little late. That is 7. We multiply all those together. So that's square root of 8,855. We'll take the square root of that, which is just to the half power, and we get about 94 feet squared if you round to the nearest whole. Okay, let's look at number 28. This is the vector problem, word problem. So 2 tugboats are being used to pull a cruise ship through a harbor. The first tugboat pulls with a force of 2,400 pounds, and the second tugboat pulls with a force of 3,600 pounds. The angle between the 2 tugboats is 25 degrees. What is the combined force of the tugboats on the cruise ship rounded to the nearest whole unit? So think about when you draw this picture, sometimes it's easier to draw it as one of the tugboats is on the x-axis and the other tugboat is the angle that they told you apart from that, which I know I'm overdrawing this, but it's 25 degrees. And then what we're talking about when we say the combined force is the vector that when we draw it out here, it is the same as if we added this blue, and I overdrew that a little bit. So let me mark that off. It's the same as if we added the 2 vectors together by placing the end of the first one with the beginning of the second one. So it's that parallelogram property. So to find this, we need to be able to add these 2 vectors together. So we need to know their positions. So this is found by doing the force of each one of them. So this one is the vector, we're going to say this is the smaller one. So 2,400, this one's 3,600. So you take the amount of that magnitude of that vector and you times it by cosine of the angle. Well, this one's at 0 degrees. And then 2,400 times sine of 0 degrees. And then for this one, we're doing the 3,600 cosine of 25 degrees and 3,600 sine of 25 degrees. So we want to find out what each of these is. So cosine of 0 is 1, because this is really the ordered pair, kind of like 1, 0. So this is going to be 2,400. Sine of 0 is 0, so that's going to be 0. And then we need to work this one out. So cosine of 25 times 3,600 is 3262.71. 62.71. So this is for this point right here. And then we need to do sine of 25 degrees times 3,600. That's 1,521.43. 1,521.43. Let me double check that. So imagine that that's the coordinates of our second vector. So you're really thinking of these as vectors. To find the resultant force or the combined force, we need to find the coordinates of this, and then we'll find the magnitude that actually goes with that. So you need the coordinates to know how where the place at the end point of the vector is. Then we find the magnitude by, remember, let's call this vector r. We take them both, we square them, and then we add them together and take the square root. You do the distance formula, essentially, or Pythagorean theorem. So this would be adding 2,400 to that. That's going to be 5662.71. This will stay the same because this is 0 plus that. Let me double check that I did that right. 5 and then 6 and then everything else is the same. So then we need to find the magnitude of this vector r by doing 5662.71 squared plus 1521.43 squared underneath a square root. So 2.71 squared, which is really big, plus 1521.43 squared. Hit enter, and then I need to raise that to the 1/2 power for the square root. So that's 5,863, and it says to the nearest whole unit, so 45864. And that would be pounds, because that's what our force is being measured in. Getting to the home stretch here, the home stretch of problems. So 29, I'm going to do B part. We're going to do completing the square to list the center and radius of a circle. So we have x squared plus 10x blank, get the x's together, plus y squared plus 12y blank equals negative 21 blank blank. So x's together, y's together, constant on the other side. We take half of the middle term and square it, so that's going to be plus 25. You need to balance that on both sides. Half of the middle term squared will be plus 36. Do that to both sides. This factors into, can't write, x plus 5 squared plus y plus 6 squared equals, that would be 4, and then plus that is 40. So this has a center of negative 5, negative 6, opposite of x and opposite of y, and this is r squared, so the square root of that would be our radius, which would be 2 on the square root of 10. Okay, let's look at number 30. It says find the standard form of the parabola that satisfies the stated conditions. Remember, parabolas can either be of the form x minus h squared equals 4p times y minus k, or y minus k squared equals 4p x minus h. Depends on their orientation. So we can tell that usually looking at this. So it looks like this is an x equals 1 for your directrix. Sometimes it helps if we just draw that out. So here's 1. My directrix is vertical. Your directrix and your vertex and your focus, remember, they all have a kind of a relationship to each other. Your vertex is -2, -1. So that means this is a parabola that is going this way, because the directrix is always below that, and there's going to be a focus that is some equal distance from here. So we're going to find that information in just a second, but that tells me what kind of orientation I have. So this is the orientation of the y being squared. If it was up or down parabola, it would be the x being squared. Okay, so we're looking at the formula y minus k squared equals 4p x minus h. So here's the things we need to know. You need to know your vertex, which we already know. That's our h and our k. And we need to know this p value. P is the distance from the vertex to the focus. And it's very specifically that distance because that tells you if it's going to be positive or negative. So you need to know how far away this is from its directrix because it's the same distance to the focus. This is a distance of 1, 2, 3. So this is 3. This is also going to be 3, so 1, 2, 3. 1, 2, 3. 1, 2, 3. But this tells me my P is actually negative here because it's to the left. So if your focus is to the right of your vertex, it's going to be positive. If it's to the left, it's negative. So let's plug in what we know. So this would be y minus negative 1 squared, because it's my vertex, equals negative 12, x minus negative 2, so plus 2. So there is my standard form of that parabola with the correct orientation. Okay, so let's talk about the next one, which I believe has to do with the ellipse. So it says convert this to standard form and then tell me the vertices, covertices, and foci. So this is 9x squared plus 162x blank plus 5y squared minus 80y blank equals negative 869 blank blank. To complete the square, you have to pull out the leading coefficient first for each one of these. So 162 divided by 9 leaves me with 18. X in the middle. Pull out the 5. That's going to be a minus 16y. Now, because you pulled that out, it does play into what we add on the other side. So half of 18 is 9. 9 squared is 81, but we have to add 81 times the 9 we pulled out. So that's 729. And then half of this is negative 8 squared would be positive 64. And 64 times 5 that we pulled out is 320. So we need to add those to that right side. So that's 320 plus 729 minus the 869. So that's 180 on the right side. This becomes 9 parentheses x plus 9 squared plus 5 parentheses y minus 8 squared. And ellipses should always be equal to 1, so you divide everything by the 180 because that's what's on this side. So that equals 1. This would be x plus 9 squared over 20 plus y minus 8 squared over 180 divided by 5, which is 36. When dealing with an ellipse, your orientation is based on which of the bottoms ends up being bigger, or I should say the value is bigger because sometimes there's a number on top too, which means it was a reciprocal. So this guy is the a squared, which means our orientation is up and down for our ellipse. So this is b squared. So my center is negative 9, 8. My vertices are based off of that 36. And this is the direction we add or subtract in. It's in the y direction. So we're going to do plus or minus 6 to our y value. So that's going to be negative 9, 2 if we subtract 6, and negative 9, 14 if we add 6. Our covertices have to do with the square root of 20, which would be 2 on the square root of 5 that we're going to add and subtract. And that has to do with the x value, the other variable. So negative 9 minus 2 square root of 5, comma 8, and negative 9 plus 2 square root of 5, comma 8. We're not graphing these, so it's okay that they're radicals. To find your foci, you need to know how to find c squared. In an ellipse, c squared is a squared minus b squared. It's inside the ellipse. So c squared is 36 minus 20, which is 16, or c is plus or minus 4. And it also follows the same orientation as your main vertices, so it's going to be to the y value. So my foci are negative 9 minus 4 from 8 would be 4, and negative 9 plus 4 to 8 would be 12. So there are all of my points. We didn't have to graph them. And then finally, for the very last problem, I'm only going to pick one of these. If you guys obviously have questions on other versions, because I'm not promising you that the one I'm doing is the one that's on the test, but if you have questions, you can obviously still email me and ask me how to do the other two pieces. But this one, we're looking for the equation of the hyperbola, which means we need to figure out our orientation to know which version that would be, if it's an x squared first or a y squared first. The center is 9, 7, the vertical transverse axis, and the horizontal conjugate axis. So here's the thing about this. So a vertical transverse axis means that's tied to your vertices, so V and V prime. A horizontal conjugate axis, that's tied to that W and W prime. The parabola or the hyperbola has the orientation that's connected to the V's. So that means this is up down, which means that we have y minus k squared over a squared, and then minus x minus h squared over b squared equals 1. So this is the version that we're looking at. The version that they've given us here, the information, this tells us that the length of this is 12 all the way. So that means from the center is 6. So center to one vertex is 6. So that means that a squared is 36. The horizontal one has 18 for its length. So that means that this distance from the center to one of these extra conjugate endpoints is 9. So that means b squared is 81. So we have everything we need now. So y minus 7, make sure you use the y value, squared, over 36 minus x minus 9 squared over 81 equals 1. All right, so you guys let me know if there's other questions that you're still struggling with, but hopefully this is enough to get you started and reviewing for your test. So I'll see everybody at our next class session on Wednesday, and good luck studying.